Hello, everyone, and welcome to ETL versus ELT cage fight using RudderStack and ClickHouse to build real-time data pipelines. My name is Robert Hodges, and I'm here today with Eric Dodds from RudderStack. Before we dive in and do some more detailed introductions, I'd like to just tell you a little bit about this webinar to help you enjoy it. This webinar is being recorded. You probably heard the message when you joined. So we will be sending a link to that recording as well as the slides out to everyone who registered for this webinar within the next 24 hours. So you don't have to take frantic notes. It's all coming to you in email. You can also ask questions. We do have plenty of time to cover these issues. We know there's a lot of interest in building data pipelines. Please feel free to put your questions into the Q&A box, which is provided as part of the Zoom menu bar, or you can put them in the chat, whatever's more convenient for you. If the questions are relevant to what we're talking about, we may take them in passing right on the slide, but otherwise we'll queue them up and answer them at the end of the call. With that, I think we have everything. So let me just do a quick sound check. Eric, sound good from your end?
Sounds good from my end. How do I sound?
You sound great. I think we're ready to go. Let's go in and start some introductions. So my name is Robert Hodges. I'm a database geek. If you can see my video, these are my books from 30 or 40 years of working on databases behind me. I've worked on everything from pre-relational systems to analytic databases. My day job is I'm CEO of Altinity, so I run the business, but I'm also pretty deeply involved in database technology. Eric?
Hi, I'm Eric Dodds, and I'm the head of product marketing at RudderStack. And I've been building all kinds of data stacks for about 10 years now, primarily dealing with customer data for use cases around marketing, attribution, advanced analytics, etc. So very excited to chat today. All right,
Great.
Quickly chatting about RudderStack. RudderStack is a warehouse native customer data platform. So we provide tools that make it easy for data teams to collect their data, to unify that data in a central store. Robert's going to talk about using Altinity to do that, and we'll give you an example. But then we also give you the ability to activate that customer data once you've unified it and modeled it. What that means practically in terms of what you get, so real-time event streaming. We have ETL pipelines that can pull batch data in from your cloud tools. We have reverse ETL pipelines that pull it back out of the data store. We provide streaming transformations. We'll dig deeply into that today. And we also do some neat things like automating deterministic ID resolution and a couple of other things that our customers find really useful.
Great. I'd like to introduce Altinity. So we're an enterprise ClickHouse provider. We have a unique value proposition that we allow you to run ClickHouse anywhere. So you could be in the cloud, you could be on Kubernetes, you could be on prem. We run Altinity.cloud, which is the oldest cloud on for ClickHouse on Amazon as well as GCP. We also are the designers of the Kubernetes operator for ClickHouse, so deeply involved in cloud native ClickHouse operation. And we have well over 100 on-prem customers, ranging from doing all kinds of crazy things with ClickHouse, everything from embedding it in software appliances, all the way up to running ClickHouse clusters with hundreds of nodes. So whatever you're doing with ClickHouse, we can probably help you. With that, let's just move ahead and talk a little bit about just this whole question of ETL versus ELT. And I'm going to let Eric kind of set the stage for this about what is the difference between these two things, and then we'll dive into some more concrete examples.
Yeah, absolutely. Well, I think this is a topic that a lot of people are familiar with, but when you boil it down, it's really a question of where is the transformation happening in the data pipeline flow of collecting data from a certain source and then moving that data through a pipeline and then eventually delivering that data to some sort of final destination, which is very often a data store. So there's been an age-old question, originally in the early days, you would extract data, you would make all the transformations that you need in order to make it fit for the downstream destination, and then it would go into the downstream destination, all nice and pretty and ready. That was often due to limitations of the downstream destination itself, right? It had very particular needs, and so you transform the data on the way there. We live in a world today where there's a lot of data transformation that can happen in the data store itself, much more flexible ability to store different types of data, different schemas, et cetera. And many data teams really want to keep an original copy of their data, right? So you load the data in its original form. And then ultimately, you want to do some sort of transformations on it, but you also have an original copy of the data. So the question is, where should you actually run that transformation? And the answer that we're going to talk through today, so there's a little preview, is you really should do both. The ETL, where you extract and transform and run the transformation before load, that's really useful for things like structured data that need some sort of meaningful transformation before they land. So we can think about things like cleaning or enrichment or even privacy. And those can happen in batch or streaming formats. We'll talk specifically about streaming transformations that RudderStack performs. ELT is useful, like I said, when you want to retain an original copy of the data. But I think more importantly, Robert will talk about different kinds of modeling and transformations that you want to run in the target system, right? If you have an original copy of the data, you can do all sorts of interesting things and build different models because you have the data in its original format. Also great for semi-structured data or unstructured data that can be difficult to work with in a streaming format.
Great. So with that background, sort of general background in this topic, let's just talk about a specific example. And I call this the path from data to enlightenment. And this is for anybody that's run a business that is digitally focused, e-commerce, for example, software sales. We're very, very focused on looking at what's happening on our website, and users are visiting, what is it they're doing there. And so what we'll typically do is collect that information, stick it in some kind of analytic database, and then use that information about site visits and user behavior to do what's called funnel analysis. So what we're really asking is, hey, people arrived at our site, that's the top of the funnel. And then what we really want them to do is to do some conversion where, for example, they buy something or they take some, they do some other activity. So the funnel analysis tracks their path as they go from different pages to actually arrive at this desired goal. This is a really fundamental operation that virtually every website does, and it is enabled by these ELT or ELT processes or ETL processes that are moving data into the data warehouse where it then becomes available to analytic tools. So one of the key things, as Eric pointed out, is these transformations that occur along the way. And I won't read this table in detail, but it just gives you an idea of the general types of things that you may do to data. So, for example, cleaning, normalizing people's addresses, normalizing things like IP addresses, just meeting certain interface requirements so that your downstream systems don't have to deal with a bunch of dirty data or misshapen data that will cause errors or things to be just missing. This goes through privacy, security, enrichment, all the way down to aggregation, where you may be summarizing data in order to allow very, very quick insight. And we'll give a specific example of it, of this type of aggregation in just a few minutes. In summary, to go from that data that you had on the website to something useful to an analyst, you've got to do these transformations. Sometimes all of them, sometimes only a fraction of them. So as Eric described in providing the context, there's really two design approaches to this. In both cases, we're collecting events from the source, but in the one case, traditionally we would transform the data in flight, and then we would put the fully formed, fully cleaned, fully securitized data into the database for tools to operate on. The other approach, which began to arise a couple decades ago, was actually to go ahead, collect the data, load it straight into the database, and use tools like SQL to actually change the data and then drop it into a table where it was accessible to tools. This this caused a surprising amount of controversy between DBAs and database engineers and people who just advocated one or the other of these approaches. I have never personally seen anybody get into a fist fight about this, but you get some pretty serious arguments where people are saying, hey, ELT is the way to go, and or ETL. And to be honest, vendors have often sort of contributed to this by pushing one or the other as opposed to both of them. And so, when we ask which is better, ETL or ELT, the real answer is just yes. You should use both of them and in the appropriate way. So this is a really good time to just go ahead and start to introduce these two products. And what I'd like to do it right now, what I'd like to do now is go ahead and turn it over to Eric, who's going to introduce you to how RudderStack works.
Absolutely. So RudderStack you can think of the main initial use case for RudderStack. We'll talk about others, but the main initial use case is collecting event stream data. Primarily is going to come from something like your website or your mobile application or your, let's say, server-side software application, right? The main type of data that we collect in the form of events is user behavior data and user events. So what that looks like is a website. So Robert showed earlier, there's someone browsing around on a website for selling automobiles. They click on a product to view it, right? They may request more information by submitting a form. They may, if it's e-commerce, they may make a purchase. There's all sorts of actions that a user can take. RudderStack provides SDKs for web, mobile, server side, and others that make it very easy for you to install the SDK and instrument and collect real-time event data with a standardized schema. This does a couple things. One, the standardized schema makes it really easy to send the data to any other tool in your stack. So RudderStack has 200 plus out-of-the-box integrations. So you could send it to your sales CRM or your marketing automation tool. One of the main use cases, though, is sending it to some sort of downstream data store, like a data warehouse, like ClickHouse, which Robert's going to talk about. And because all of the events that we collect have a standardized schema, it makes it really easy to perform analytics on them because the data is getting flattened out in the warehouse the exact same way every time. So that's a really primary use case for RudderStack. And we'll dig into some of the transformation stuff here in just a minute. Sorry, let's go to the next slide, Robert. I don't have those in front of me. Okay, so we have customers all across the board. A lot of customers in the direct-to-consumer space, healthcare, finance, etc. One really significant thing about RudderStack in terms of the way that the product is architected is that we don't store any data. So our opinion as a company is that we want to be the pipelines that help you collect clean data, make sure it's trustworthy, deliver it where it needs to go. But your source of truth should actually be your own data store. And like I said before, we have very powerful features that allow you to transform data in flight. And then also, because you use your data store as the source of truth, we provide pipelines that allow you to pull data out of that data store source and send it back out to the rest of your stack. So a quick example of that would be, collecting website events, building some sort of model around, whether a certain type of browsing behavior would lead to a purchase, and then pushing that data back out of the data store into your marketing tool so that if someone exhibits that behavior, they have a flag now, you can segment them and then send them a promotion that might help them convert. So that's a quick overview of the use case and some of our customers there. This is our architecture. So again, you can see that we don't have a data store ourselves. So you would install the SDKs you see there on the left-hand side. So again, web, mobile, and others. The event stream is sent in real time to downstream destinations. So marketing tools, analytics tools, CRM tools, but also data infrastructure, right? So you can see that we can feed Kafka or Kinesis or other tools directly in real time. A lot of our customers have pretty significant streaming setups already for other parts of the business, and customer data tends to be a pain point there. So a lot of our customers will feed our event stream data directly into an existing stream that's running in Kafka or Kinesis. And then the raw events are also sent to the data store. And then the other pipelines you can see there, we have a cloud ETL pipeline. So this would be where you would say, pull your CRM data from Salesforce into that data store as well. You can join that data with the event data to build models. And then the last pipeline you see there is reverse ETL, where you can take that data back out and send it to the tools that need it. You can see in the middle, transformation, identity stitching, and data governance. In identity stitching, we have the ability to produce a baseline deterministic ID graph in your data store based on the data points that you're pulling in through event stream and cloud ETL. A lot of our customers find that very useful. But you can also run transformations. And I'll go a little bit deeper into the explanation here. So let's say that, for a particular use case for transformations, the marketing team or the sales team changes some sort of field in a downstream destination. And we are sending form submits from our website to, Salesforce, our CRM. Well, if the revenue ops person changes a field, it's not going to map correctly and the leads won't get delivered, right? Which, always creates a massive fire drill and everyone stops what they're doing to figure out what's going on. Well, traditionally, if you have a pipeline like that set up, you have to go back to the website, re-instrument the website to get the data point correct so that it matches up with the downstream field in Salesforce and do a full redeployment. And it takes a while to fix that. With RudderStack transformations, you can actually modify the incoming payload in flight. So sales changes the field, someone raises an alarm bell, holy cow, what's going on? You can actually go in and just update the key in the payload that's causing the failure because it doesn't map correctly. And all the payloads going to that particular destination will now have the updated data that maps to the correct field name in Salesforce. And you fixed it in a matter of minutes by writing a couple lines of JavaScript or Python, as opposed to having to go back and redo instrumentation on the website. You can do whatever you want with JavaScript and Python, even hit external APIs to enrich payloads. But that gives you a sense of what's happening in the pipeline with our transformations feature. I already talked through some of this, but let's get deeper into the use cases. So what do our customers use transformations for? One, they use it to ship data projects faster. So again, you don't have to, in order to achieve some sort of downstream use case, you don't have to go re-instrument your website or write a bunch of code that's going to run in your website or app. So one explanation or one example of that would be, let's say that you want to collect location data based on some user's IP address so that when the data hits the downstream system, your marketing or sales team has the location of that customer. They can give them information that's relevant to that particular location. Well, instead of setting up an API call that happens on the client side or in your app, you can actually just collect the event. It includes the IP address by default for that particular user. You can hit an external API, again, by writing some simple JavaScript or Python, reverse geolocate via any sort of reverse geolocation API, and pull down the location, append that to the payload, and it gets syndicated to the downstream systems that need it, including your data store, which again enables advanced analytics, having human readable locations based on IP. So we have a lot of customers who want to implement use cases like that. They would usually take weeks or even months and a ton of code and a ton of tickets for the dev team. But data teams can actually ship these things in hours or even days. Our customers also use transformations to secure data and build trust in it. So you can see an example here in this screenshot. Privacy and compliance is becoming a huge issue in today's environment. It always has been, but data breaches becoming more and more critical, especially as regulations tighten down. With RudderStack transformations, you can actually enforce different policies that apply on a destination by destination basis. So when we think about data security and governance, there may be situations where you want to hash information going to a data store where your data science team is building machine learning models, right? You don't want sensitive PII in the data set that's being used to develop a model, right? Well, with RudderStack transformations, you can hash that information before it gets to that destination while retaining that information with other destinations that might need to use it. You can strip PII, you can mask it, you can block events, you can completely remove data, and you can even encrypt data. So lots of things you can do. And again, you can run these transformations on a destination by destination basis. So you can think of it almost as a suite of tools that allows you to customize compliance, for each destination in your stack. The last major category that we see is the ability to do customizations and maintain flexibility. So that was the example I gave at the beginning around Salesforce, right? So there are all sorts of places that we need to send customer data and customer events. With transformations, instead of having to go back and re-instrument, you can actually customize destinations fully using transformations. We have even had a lot of customers send data to a webhook destination and use transformations to completely modify the payload to send data to some internal or external API where RudderStack doesn't necessarily have an integration. Also, cost control is another big one. Let's say you have a downstream analytics tool. It's expensive to send data there. Well, you could filter or sample events using transformations in order to control costs there while still having enough data to perform analytics. So those are a couple of high-level use cases and how people use RudderStack transformations. Happy to answer questions at the end.
Got to get my video back, or audio back on. Thank you, Eric. So that was a great introduction to RudderStack. What I'm now going to do is go ahead and introduce ClickHouse. So let's dive straight in. For many people, ClickHouse is something new. It's an analytic database. It's open source, and a way to think about it is it's a lot like the open source databases that you've been using, for example, MySQL or Postgres, in that it understands SQL. It runs virtually anywhere, and it is open source. So very few restrictions, particularly in the case of something like Postgres. You can use it in practically any way you want. And people have built enormous systems on these and, of course, been very successful. Where it differs from these databases is the analytic capabilities. So things like being able to run, to store the data in columns with very high compression, being able to do parallel and vectorized execution so that you can, queries that might take you literally hours on MySQL will complete in seconds or less in ClickHouse. And then the ability to scale to enormous amounts of data. We have customers that run hundreds of nodes and databases sizes running into tens of petabytes. So as a result of these capabilities, it's become a very, very popular low latency query engine for SaaS analytics and many other applications where people need cost-efficient query and very, very fast, stable response. Just a little bit about the architecture. Won't belabor this, but it's a single single process. Owned C++ code can read columnar data from normal block storage, so an attached file system or something across a network like Elastic Block Store. It can also read data very well from object storage. Beyond that, it has many of the normal things that you expect with databases, but a key feature of ClickHouse is it does not, unlike many databases, it does not depend on having an enormous amount of information in memory to function quickly. Speaking of quickly, why is it so fast? And I'll prove this in a minute, but practically anything you can think of to speed up a database is used in ClickHouse. So everything from codecs that transform data on input to make it much smaller before it's handed out to compression, down to the ability to run distributed queries across tens or even hundreds of nodes if necessary. These are all features of ClickHouse that come out of the box and can be applied to your applications to make them go fast and have stable response. So it's nice to talk about fast, but it's better to show it. So what I'm going to do here is cut away from the slides for a second. Let's go ahead and we're going to do a demo. So let me pull up, this will just take a minute. Let me just pull up my text here. Give me 1 second. All right, so what we have here is a database set up in Altinity.cloud. It contains 1 trillion rows. Let's just go count them. So here we go. Put the query in, we'll count the rows, and boom. If you can read that, there's no commas, unfortunately, or periods that you're used to, but take my word for it, that's 1 trillion rows plus 16,680. This came back instantly. Can't take any real credit for that because databases typically or often just remember the number of rows in a table. What's more interesting is actually ask it a real question that requires to go read some of that data. Let's do that. This is temperature data that we're looking at here. I'm going to scan the temperature data to find the maximum temperature that was recorded by a device numbered 2555. And let's go ahead and run that query. And so there it goes. That is scanning using an index that allows us to loop into sort of the right part of the data set. We had to read 1.56 million rows, but we got done in 0.04 of a second. And in fact, if we run it again, we're going to go down a little bit because there's some cache heating effects as due to blocks being present in the buffer cache. So that's pretty fast. Let's ask a question. What was the maximum amount? What was the day that we actually hit that maximum level? So let's go run that query. This is a little bit more complicated, and it's going to ask a little bit more data, but it's the kind of thing where, hey, you want to see, you're maybe trying to figure out if this thing is functioning correctly. Did it have the max temperature on the hottest day? We run that, and this query takes a bit longer. So we're scanning more information, and so it's taking 3/4 of a second. Well, in ClickHouse, this is the kind of thing where if you did this a lot, you might regard this level of performance as unsatisfactory. So fortunately, there's an answer to this, and that is to put the data in what's called a materialized view. I'll explain what they are in a minute, but let me just show them, show what the effect that they can have. This is a view which basically pre-aggregates the data that we're asking for, the maximum temperature and the day that it occurred. And if we ask this view, what was the maximum temperature and on what day, we get an answer back, in this case, in 17 milliseconds. If we run it again, because of these mild cache heating effects, it actually goes down to less than 100th of a second. This is the kind of thing that can actually render, can actually give you a response back in less than, well under the time that it takes to render a page. So it means your applications can be asking the data warehouse about information that is then populated directly onto the page. This isn't just fast. This is the kind of thing that actually enables new businesses. So that's the demo. I hope this gives you a sense of the power of ClickHouse. Let's talk a little bit more about actually focus on this question of transformations. So we're going to come back, kick off our slideshow again. And let's just talk about loading data in as, and so typical data will show up as JSON. This is an example of the temperature data that we were reading. So there it is, simple JSON. This is pretty easy to move into the database. You can, ClickHouse can read JSON data. It has about 50 or 60 formats that it supports, everything from CSV to simple values to things like Parquet and Orc. And you simply insert them in, tell what columns you want them to go in, and ClickHouse will just, in this JSON case, just pull the data out and stick it in the right column. So that's pretty simple. But the fact is that when we're actually reading large amounts of data, we want to do a little bit more than that, because we may want to transform the data, which is something we've been talking about, for a variety of reasons, for performance, for things like cost efficiency, so on and so forth. So what we'll do is we'll take advantage of that ability to read the raw data very quickly, and we put it into an input table with using what's called a null table engine. So we don't store the data, but what we do is we have a materialized view, which looks at that table, and every time a block of data is placed into this table that doesn't really store information, we trigger a query that runs over that block and sticks the results in another table. So this allows us to do an on-the-fly conversion very, very quickly as each block of data arrives. The blocks can be small or they can be very large. They can often run into millions of rows. And the materialized view will do that. So as a result, loading data would be as simple as having this input table where we just read that event in as, so we just have the event. And then we have a target table, which is the converted readings. And this target table then has a bunch of optimizations on it, like it's using specialized codecs that can reduce the data by up to 99% before it's even turned over for compression, and other tricks like that that allow us to have incredibly cost-efficient and performance storage. And the materialized view shows you it's just a SQL query. So basically, it runs a select. And what it's doing is picking out these values from the event and converting them like to the right data type. We could, for example, also handle things like date time. There's a bunch of different conversions, handle dates, including dirty dates that can't be converted, so on and so forth. And then another common trick is we'll even keep a copy of that original event data just in case we want to look at it later or pull more columns out of it at a later time. So this is very straightforward and it's a standard way to attack storing this information, loading and storing information. One of the other important things is that we can also do arbitrary transformations, and here are just some examples. Like, for example, we can zero out social security numbers. We can hash email addresses. We can even encrypt things using AES encryption so that the data is transformed on the fly to something highly secure that cannot be decrypted easily. Moreover, we can actually do joins as the data arrives in this table. We can join it with data from other tables. So this allows us to supplement the information that's arriving off the real-time stream and add denormalized data, which will then make our queries that much more efficient, because the extra data that they're looking for, the supplementary data that's necessary to make sense of these temperature readings is already stuck on the records and available so that tools can access it easily. So this is kind of a summary of the transformations that you can do inside the database. They are basically driven, of course, off SQL and take advantage of the fact that we can build these materialized views and, in a sense, build what you might even call mini data pipelines inside the database that run extremely fast across millions and millions of rows. Let's get to the final part of the talk, which is how to use RudderStack and ClickHouse together. So I have a very simple demo that I'd like to show you in a minute here. But basically what it's going to do is it's going to take that use case that we had, that we showed at the very beginning of the talk of reading event data off a website and then pushing it into the analytic database. So in this particular case, within RudderStack, I'm using RudderStack Cloud, and I'm going to define a source, which is a webhook, and that's basically forms a URL where I can post event data into RudderStack, which will then be automatically moved to a destination, in this case, a ClickHouse destination, that can apply simple transformations. In this case, the only transformation I apply is zeroing out credit card information. And then the result gets placed into ClickHouse. So again, I could go into the details, but it's just simpler to show you. So let's just drop out of the slides and go over to RudderStack. We'll back up here. So this is what it looks like when you're inside RudderStack. And I want to, one of the things that I think is a key point here is I put this together in about 90 minutes. It's very, very quick. And I'll show you some of the efficiencies that you get from why it was so speedy. I have no background in RudderStack, and yet I was able to set this up and connect it to ClickHouse. So here we have let's go ahead and look at connections. This is my simple data pipeline. So sales data is the name of my webhook, which I can then post events to. The destination where the data are going to be placed at the end of the pipeline is ClickHouse. So it's just one-to-one. Of course, as Eric said, you can be much more sophisticated than that. But let's go ahead and look at this sales data. And one of the cool things that RudderStack allows you to do is watch live events as they're passing through. Let's go there, and we don't see any events here right now. So what we need to do is fire up the demo and actually generate a few events. So I'm going to run a very simple script, which is just going to post 3 events that represent sales. And you'll notice that they have, you can see this from the data, you'll notice they even have a dummy credit card in there, which we're going to show that RudderStack can remove. So, whoops, let's go ahead and run that. So here are the events. They're being loaded, posted into RudderStack at 1-second intervals. And this immediately shows this really cool feature that as we're watching these live events, and here you see them directly inside the UI. And in fact, we can go in and now we can look at the information that RudderStack has provided on this. And so, for example, I posted this message with the sales information. RudderStack is then supplemented with additional information that allows it to trace back to the source, understand the event type, so on and so forth. So this is really cool. You see this live in real time, and it allows you to diagnose, to look at and then diagnose problems, and also assure yourself that things are being transformed correctly. Let's back out of this a little bit and go over to the destination. So here's my destination, and I do have a transformation here, which is to remove credit card number. Let's just have a quick look at that. Details. Here you go. Very simple piece of code, but it could be as complex as I want. It just says, hey, if you see a CCNum property on this event, just go ahead and zero it out so that the credit cards will disappear. Let's just back up a little bit here. Oops, go back to destinations. And this time what we want to do is now look at the synchronization, which is where the data is actually applied. And what we see is, actually we'll go ahead and sync it. It's configurable how often it does this, but we should see it go ahead and apply this data shortly. And while we're waiting, let's actually go over and look at what's going on inside ClickHouse so that you can see what RudderStack is doing for you. So one really key thing that RudderStack does is it will automatically create tables corresponding to your events. You don't have to do anything. They just show up in RudderStack and they're available. 2 key tables that get generated here. One is called tracks, and this is basically a table that gives you a list of all the events of any type that have arrived, and we can just look at the kind of data that we have there. So select star from tracks. There it is. You can see the events. These come through webhooks, so on and so forth. So we see this information showing up. And then the other information that we can see is the actual events themselves showing up in this product sale table. And let's go ahead and look at the data that we have there. So this is the information that's actually getting loaded in from RudderStack and placed into ClickHouse. And one of the things that we can see is that credit card number has been successfully zeroed out. So this shows you the end-to-end, this demo basically shows you the end-to-end movement of this data. And as I say, one of the things that really made this simple was the fact that RudderStack does provide a lot of this stuff automatically. So using RudderStack Cloud, I didn't have to set anything up. RudderStack itself would even create the table where the tables where the data was going to land. And then finally, of course, I'm running the database itself in Altinity.cloud. So I didn't have to set that up either. So this is the kind of thing where if you had to get this functionality working, you could basically have something pretty plausible running in a half a day. It's very powerful. So with that, I'm going to go ahead and talk a little bit more, return to the presentation. Eric, any comments on this? Any other things you'd like to add on capabilities while we're here
No, Robert, that was such a wonderful demo. I think you said it really well in that, in 90 minutes, you were able to get a simple pipeline set up. You keep in mind that our SDKs handle a lot of stuff for you. So if you install the SDK in your website or your app, we collect a lot of context, a lot of information. And then if you want to go back to the connection screen really quickly, you mentioned this, but just to reiterate it, let's say you wanted to send that sales data to email marketing tool, a CRM, you can simply add a destination. And we have, again, hundreds of different destinations. And so you can think of us as sort of infrastructure that removes the need for you to do all the painful stuff like running an event stream pipeline, building an SDK, or building integrations. We're really good at that stuff, so you can get the right data to where it needs to go.
Exactly. And we, on the other hand, we run Altinity.cloud. We remove the pain out of running these large, very large databases. Okay, so let's go back and complete the talk. So just a few notes here on how you would move from, here's the schema management. Let me just talk about this very briefly. So one of the cool things, as I mentioned, was that as the events are applied, RudderStack will have a look, and if the table's missing, it'll just create it automatically. Moreover, it will, if you have additional columns showing up in your messages, they will be added automatically as well. It's very powerful. So we talked about tracks, product sale, the fact that schema is created automatically. As you move to build a production system, one of the things that you do with ClickHouse is you tend to apply these transformations, for example, around compression, codecs, data types, things like that. So you can take this, if you want to really hone this and make it much more powerful, you can go ahead and change the product sale table directly and put in your own schema. But the other thing you can do is you can just build a materialized view that takes that data that's coming in from RudderStack, applies these transformations as I showed you in the previous section, and then sticks them into a final table, which is where your apps run from, and where you can get, for example, very, very efficient disk storage, very, very high performance. So this would be one way to take this demo that we have and move it onto a production footing. Just a little bit of a summary, returning to our question of, like which of these do you use? Well, the answer is both for transformations. And this chart here kind of gives you a sense of what which one you would prefer for different things. Again, you don't have to read the whole thing, but I would say that, if I were building this pipeline, the cleaning of data and making sure that it has a consistent interface and no junk in it, that's something that's really good to do in RudderStack. It's got a general purpose programming language, has a bunch of transformations built in. That's something I definitely do it in RudderStack, and I would not do it in ClickHouse. That's going to make this much easier. On the flip side, when it comes to aggregating data, ClickHouse was born to do this. So this is something like if you're trying to do that temperature exercise I did where I'm trying to find for a particular sensor max temperature on what day, this is what ClickHouse is designed to do. So you do that there. Everything else, you pays your money and you takes your choice. So you can do them in either location. It depends on your application, which one is better. And in fact, in many cases, they just both work and there's not that much difference in the finished system. So final topic here is reverse ETL. And Eric, do you want to talk about this for a little bit?
Absolutely. So reverse ETL is kind of a funny name for this pipeline. Those of us who work with data every day would just call this sending enriched data out of your data store to the tools that need it. So let's think about the product sale data example that Robert talked about. So you have a bunch of different purchases. And of course, when you send that data to a tool like ClickHouse, you're going to run complex analytics on it to understand things like user lifetime value. Perhaps you're going to group users into a segment where they are brand new purchasers, first time customers, right? You can run those models on the event data and understand, we've never seen this person before. Today was their first day visiting the site and they happen to make a purchase. Maybe we want to engage them and make sure that they come back to us as opposed to just making a purchase and leaving. All of those things are features or metrics that you're going to compute in ClickHouse. And when you compute those, it's very helpful to understand the business, but really how you move the needle is by saying, okay, well, if we know that these are first-time purchasers, let's get that data back into our marketing tool so the marketing team can send them, a thank you email with some sort of coupon or promotion to try to keep them engaged. That's exactly what reverse ETL does. So within RudderStack, you can actually think about reverse ETL as taking a table. So this, could be really any sort of table. A lot of times this is a view that's materialized, basic, an output table from some sort of computation that you're running. And it will turn each of the rows in that table into a payload that it will then send to downstream destinations again. So it'll take, a row generally, for the use case of a user who's a first-time purchaser, there's going to be one row per user in that table. And you want to send that updated user record to your marketing tool with the flag, first-time purchaser or something of that nature, so that your marketing team can use that flag to drive segmentation. It is as easy as that. You can connect a table and it will just, sort of package the events into a basic JSON payload and send it. You can also edit the JSON. So this is where maybe you need to add a constant or some other data point for some sort of particular destination. So you can actually edit the JSON. You can also create pipelines by just writing SQL in RudderStack. Let's say you have two tables and you want to do a simple join to produce, to produce some sort of additional table that combines data from both of those. You don't want to do that in your data store for whatever reason. You can actually just write those SQL queries in RudderStack and it will run the job and then, again, provide you a table where it can send each row as an individual payload. Pretty cool, very, very useful. The last thing that I'll mention is we also have a feature called audiences. We didn't put it on the slide. We also have a feature called audiences. So let's say you build an audience of maybe users that haven't, made a purchase in some period of time, right? Haven't made a purchase in the last 30 days. Well, you may actually want to send that audience to an advertising tool so that you can, serve them ads with some sort of promotion or something to re-engage them. Our reverse ETL tool also has the ability for you to send an audience like that to advertising tools like, Facebook, Meta, or Google Ads, and lots of others. So lots of cool things you can do, but the punchline is that you can do all sorts of powerful enrichments and computations in a data store like ClickHouse through Altinity, and then you can actually syndicate that value to the rest of your stack and the business tools that need that data in order to improve the customer experience and business performance.
Great. Thank you very much, Eric. And I want to say that the reverse ETL capability is really interesting because this is something that data warehouses natively don't do particularly well, particularly, especially cases where you need to send notifications to a diversity of applications. The most ClickHouse can really do in this area is to go ahead and pop something into a Kafka queue. We have the ability to show windows on arriving data. So there's also that, but by combining this with RudderStack and the reverse ETL, you get a much richer set of things that you can do with the data as it changes in the data warehouse to deliver it to people who actually need it. So with this, we're pretty much done with the content. Let's just summarize very quickly. So the cage fight between ETL and ELT, you can still do it if you want, but it's not necessary. The best thing to do is to use these tools together. They fit well hand in glove. You're going to need both of them for real systems, and you should use the transformations in each part of the system that are appropriate. So RudderStack has this very rich set of tools to move and convert the data in flight. And that includes, as Eric says, the ability to then detect changes, interesting things that are happening in the data warehouse to that arriving data and propagate them back out to applications that need them. ClickHouse itself has this enormously rich set of functions, as well as a comprehensive SQL language that allows you to do very powerful conversions on data at rest. We showed you the principle of materialized views, but really your imagination is the only limiting factor. ClickHouse can do practically anything inside the SQL language. And if you want to get off the ground quickly, as I did over the last couple of days, use RudderStack Cloud and Altinity.cloud. You can bring up your database quickly. You don't have to start the pipelines, and the built-in features of RudderStack basically allow you to build a chunk of your application with very little effort in a very small amount of time. So with that, we are done. Just a little bit about Eric. You want to just remind people why they should come visit you and what they should do there?
Yeah, absolutely. I think if you are putting a lot of, let's say, manual labor or sort of low value engineering effort into things that relate to customer data, pipelines, SDKs, streaming events, we're not a replacement for the Kafkas of the world. We would feed data to a Kafka. So if you're doing a lot of integrations work or other things where you think, man, this is just every time a ticket comes through, this is a huge pain. These pipelines are difficult to scale or difficult to manage or, expensive, especially with respect to engineering time. We can make your life way, way easier by getting clean, standardized data, not only to a data store like ClickHouse, but also to the rest of your stack. So if that sounds interesting, stop by rudderstack.com. You can sign up for free, use all the cool stuff like Robert did, or feel free to shoot me an email, eric@rudderstack.com. Happy to dig in and answer any other questions.
Great. And the reason you should come visit us is pretty similar to what Eric just described. Anybody can use ClickHouse. It downloads on a laptop in about 60 seconds if you have a decent network connection. But if you find that you need help using it effectively to build applications that are highly performant and that use this rich feature set effectively, we can do that. The other thing is we can help you run it. And as Eric said, you don't want to spend all your time just doing these low value infrastructure activities. You want to build applications that actually deliver value to customers. So we have the ClickHouse Cloud, or excuse me, not ClickHouse Cloud, we have the Altinity Cloud, which runs ClickHouse and is designed for SaaS applications that are delivering real-time analytics 24/7. We can run these, we can manage it both in our own cloud, but also in your Kubernetes clusters. And then we have the ability to support you as you run ClickHouse in your own unique environments that are self-managed, for example, air-gapped FedRAMP systems. That's something we're working on right now. We also have the best ClickHouse support team on the planet. They are just wonderful. And so these are people who can basically take that learning curve that you get with data warehouses, smooth it out, and also allow your teams to pivot away from the ClickHouse application once it's done, go off to other things, and still have somebody who's covering the infrastructure for you so that you can operate successfully. With that, we have a few minutes left. We can open it up for questions. I don't see anything. Let's see, I don't see any recent questions, but Eric, you mentioned that one of the things I think is in people's minds is open source. Do you want to comment a little bit on open source and how that relates to your cloud and how people should think about that?
Yeah, 100%. You know, most of our customers, so our product, you can go in and look at all the code on GitHub. You know, most of our pipelines are open source. All of our integrations code is completely open source. We value transparency on a really high level. But because we don't store data, most of our customers run RudderStack Cloud. It's just a lot easier. You know, you don't have to deal with a Kubernetes deployment, et cetera. So yes, open source, hugely important to us. And please go check out our GitHub. You know, if you're going to run it in production at scale, most of our customers find that running the cloud product, you know, they just save a ton of engineering time on the deployment side. So,
yeah, I think we have a similar approach to open source, and this is one of the reasons why we work with RudderStack right from the start. We work with open source ClickHouse, so you can just design your whole application on a laptop. You can run it, as I said, anywhere you want. You can be in our cloud, but you know, if you decide you want to move somewhere else, or you know, part ways, hey, no problem, because what we're actually automating for you is 100% open source ClickHouse. We actually do our builds 3 years of maintenance on between cloud versus self-managed. And we have a lot of people that are operating in Kubernetes, and our goal is just to make it make ClickHouse as open as possible, give you as much freedom as possible. I think that's essential if you're building systems that are going to be robust and will continue to operate as you navigate new business problems and economic conditions. So I think Eric, I think we're done. I'd like to thank you for participating and helping us out. Thanks to your staff for helping to set up this demo.
Absolutely. Thank you for having us.
Great. And thank you, everybody. It's been a pleasure. If you have further questions, feel free to contact us at Altinity or Eric's team at RudderStack. We'd love to talk to you. So thank you very much and have a great day.